Hi everyone and welcome to this complete walkthrough where I'm building an AI powered level 1.5 support network operations center and security operations center workflow using n8n. Over the next few sections, I'm going to be taking you through every stage of building an intelligent autonomous monitoring system, one that doesn't just report issues but also understands, classifies, correlates, and escalates them automatically. The idea behind this project is simple but powerful. Take traditional NOC and SOC monitoring, as well as traditional support, IT support, which usually relies on dozens of dashboards, human triage, and manual ticket creation, and bring it into an AI assisted era. I want the system itself to read logs, understand what's going wrong, categorize incidents by type, and even determine their urgency. It should be able to decide what to escalate, where to send it, who should act on it, and how. That's what this workflow does. It starts by ingesting raw logs directly from Google Cloud Platform. So we will expand our scope also to AWS, also to Azure, Microsoft Azure, also DigitalOcean. Also ingest logs from Optics, that is from SolarWinds. We also are looking at doing the same with Ops Genie. So any raw logs ingestion will be integrated to any platform that can be able to provide the logs. So the logs are the kind of unstructured data a human analyst will see. Then using the OpenAI's language model, it will analyze every single log entry, identify patterns, and also predict the causes. So we'll be able to even generate root causes and also group them into meaningful incident categories, just like maybe billing issues, database connection errors, load balancer is down, instant startup failures, or even scaling events. From there, it aggregates similar problems across services and then calculates the severity levels based on how many times each issue has occurred. Then we will be able now to, because we've also connected the node for ServiceNow, we'll be able to create a record because most organizations use ServiceNow for incident login, ticket creations, requests, yeah, and also assignments of groups and individuals who are supposed to take care of this particular issue that has come up. And then we'll be able to also update our internal database through an API and then assign that incident to the right engineer. And finally, send a neatly summarized email notification to the stakeholders. Let's say, for example, like an issue where we see maybe organizations sending notification that we will not be able to complete payments because there is a downtime. So that is something this particular workflow will be able to catch early and then also notify the stakeholders, assign, and then we can be able to start tackling that particular issue and see whether it's AI resolvable or it needs a human AI collaboration. So the entire chain runs automatically, no human intervention required until a critical issue appears. By the end of this walkthrough, the system we are building will represent the foundation of our level 1.5 support, which will be intelligent enough for the NOC and the SOC. And then it will be a hybrid. Of course, it will be a hybrid between human oversight and machine-driven decision making. Okay, so for the architecture and the design thinking, so before we even jump into n8n, we will like to start with the architecture in mind. So the workflow follows a logical sequence. So Of course, we will get logs from AWS, from Google Cloud Platform, from Azure, OpsGenie, Optics, that is SolarWinds, and then we'll be able to ingest. After we ingest, we will do classification, and then after classification, of course, move to aggregation just to see how many, or maybe the count for this particular issue has occurred how many times, so that we can be able to log, so that we don't maybe log false issues, and then of course escalate that to, or so it's escalation, uh, and then stroke assignment to a group that is supposed to take care of this particular issue, and then we will notify the stakeholders. Think of it like an assembly line of incidents. Each stage adds more context, more intelligence, and more action. So ingestion will bring in the data, and then classification will transform the raw data into something meaningful, and then aggregation detects, yeah, of course, the way I just said, repetition, and then escalation converts insights into actionable tickets. So we will be able to use ServiceNow for that, and then notification closes loop by communicating with humans. So let's say even maybe an error has been occurring, and then the humans have not been able to catch it on time. So this particular workflow will be able to assist on that. So one of the guiding principles here is autonomy with accountability. That means the system should act on its own when it's confident, but always leave a traceable audit trail, a clear record of what it saw, why it acted, who it informed. Yeah. So for example, every AI categorization result is time-stamped and stored. So when it creates a ServiceNow ticket, it logs the incident number. When it sends an email, that communication is also recorded. This traceability ensures that even though the system runs autonomously, it's still fully auditable, and also it relies on humans as well, human intelligence. So in terms of the design, I've kept each n8n node modular. If I ever want to switch from OpenAI to another model, or from ServiceNow to Jira, I can do that easily. So the workflow is also designed to scale. So like for this workflow, for the testing purposes, we used 500 logs. It's also cloud ready, and then it will run lightweight containers, yeah, so that we can be able to even put it on cloud. Yeah, so that was the architectural mindset. Yeah, I think we can move now to the start of the workflow. So the workflow, the first step is to ingest and also log preparation. So we will start with so as you can see, we have a scheduled trigger node. So this one defines how the entire workflow should run. Yeah, and I've set it to like 5 minutes. So it's a trigger for that. It's supposed to run every 5 minutes, and then it's configurable. You can set 10 minutes, yeah, or even continuously stay connected just for live login feeding. Yeah, then the next step we have a read write node. So this one will take in the GCP logs, and then each line of the log will have fields such as timestamps, service name, the severity, and the message content. So and then we'll have another node for extracting that particular file, and then it passes this CSV into structured JSON objects. After extraction, I now have like 500. From here, you can be able to see we have 500 logs. Let me just see if I can increase. Yeah, so we have like 500 logs flowing through the pipeline. So each of the logs is now structured and then ready for processing. So at this stage, maybe we can just see how it's the model is running. Yeah. So I think now we can move to the next step, which is the AI classification with the OpenAI. This is currently what is now happening here. You can be able to see uh, the model is executing. So we have the model, the OpenAI model. So here we are just we configured a prompt that will tell the model exactly how to behave. So I just inserted some prompt that you are a support agent classifier or incident classifier, and then analyze the following log and return for us a structured JSON object that will include the category, the root cause, the action type we need to take, the confidence, and of course, the handler. So this prompt will guide us, will guide the model to think like an analyst, not just to be able to summarize, but also to be able to understand what's going wrong operationally. So each log entry is sent to the model individually, and then it reads the text, identifies patterns, and it's able to even classify it. For example, if maybe one log mentions something to do with billing is disabled for this project, the AI classifies it as a billing issue and marks it as a as an issue that requires human intervention with a confidence of 0.9. If the log says connection refused or failed to connect, it becomes a connectivity issue with so this one can have a possibility of an auto-fix action because such problems might be solved automatically by maybe restarting a service or checking the infrastructure health. So this process turns unstructured logs into structured insights. So every entry now has a clear label and an estimated confidence score. So by the end of this stage, the workflow holds like 500 structured objects, each one explaining not just what happened, but also what might need to be done about it. So we now move to the next step as the model runs, because the items are too many. So we will move to cleaning and the context enrichment. So here I'm using a code node to be able to clean and also enrich these particular results. So sometimes the model outputs might include formatting like line breaks or even escaping new lines. So this can even break the JSON parsing. So the code node will take care of that. So it will sanitize the output, pass it safely, and also add the original logs metadata. Yeah. So things like the timestamps, also the service names, the severity, and also its original payload. So this will ensure that every AI-generated insight stays linked to a particular original event which is traceable. For example, maybe I can go back and just explain the billing issue. So the billing issue was classified, and it came from a notification service that happened at this particular time on a specific day. So this contextual grounding is very critical in supporting IT support, SOC, and also network operations. So I was thinking maybe without these, the incidents may lose their origin, and even their root cause analysis becomes something like a guesswork. But for this kind of enrichment, we will be able to see how the categories are able to repeat themselves across services. So I think so for the code it's easy. It's just a matter of cleaning and enrichment. So uh, we can move to the aggregation, where we are doing the aggregation of incidents and also pattern detection. So here we are doing something where this is where the correlation comes in. Instead of looking at individual logs, we will now group them into service and category. So let's say the output reveals something like a billing issue that appears 143 times in service A, and then 35 times in customer service API, and then maybe 23 times in a B2C service API that's supposed to dispatch money to the customers. So this aggregation will transform the workflow from a log level monitoring into a service level incident detector. So I can now visually identify clusters where things are consistently failing, then also assign severity based on recurrence. Yeah, so I also used the code node to calculate the count, which adds a numeric field, which is an incident count for each service category. Yeah, so you've noticed by once the workflow will finish, it will have reduced the 500 items to a reasonable number, because most of these logs in where we normally get them, that is from Azure, AWS, GCP, Opsgenie, Optics. It's a repetition of logs, because when it tries to do something and then it's not happening, it logs an entry. So the logs may become noisy, but now with this particular workflow, it will be able to reduce the number, yeah, to a reasonable number, and then it will also have incidents which are distinct. Okay, now I think we can move to the incident classification and classifier. So it's our next node here. So the next incident classifier node will determine what happens next. So let's say, okay, it uses a very simple logic, but enforces disciplined triage rules. So if we will have something like if the issue is critical, the count must be 50, above 50 in this case. So, and then this is something that is configurable, and then it will depend on each organization. And then we will have major incidents supposed to have a count of between 10 to 49. Then the minor will have 3 to 9. Informational may have less count from the logs aggregation. Yeah. So it will. So this one maps the critical issue will be able to be created on the ServiceNow incident, notify engineers, and log in database, of course, through our API. And then the major, we can do an API update to our database, and then the minor, we can log internally. But this one, the incident classification and escalation, will entirely depend on the configurations of each organization. So then this rule will be based, the rule-based layer will ensure that the AI doesn't just produce insights, but it also drives actions proportionally. For example, like the issue I've been talking about, the billing issue in service A, if it occurs 143 times, that becomes critical, and it's automatically escalated, because it seems like there is no service which is going to be up, since there is a billing issue that needs to be fixed. And then for the maybe scaling event that occurs 14 times its major, and then it logs, yeah, it also appears into a ticket, and then it will get fixed. So the output for this particular node will give us structured escalation decisions for each incident. I think now we can move to ServiceNow. Yeah, so ServiceNow creation. So now the automation transitions from analysis now to action. So the create incident node connects to ServiceNow REST API. Each item becomes a ServiceNow record with a short description, a category, full description, with counts and timestamps. Then we will impact and set an urgency, yeah, which is critical. Depends on an issue. And then so that number will also be stored in our workflow data, and then we will also have something like an incident number, which we can be able to log in our API. And then next is a HTTP request node, which we will post that particular data to our internal API. Then this keeps the organization internal incident database in sync with ServiceNow. And then finally, we can be able to also send that to the assigned engineers via the email node. So we also have a node for getting the incidents. So the reason we have, after we create, we are having the getting, so that we can be able to pass these to a model that will decide which incident will be solved by which incident. So in ServiceNow, we normally have the assignment groups. So from the assignment groups, you can be able to assign an incident to a certain group, so that they can be able to take care of that particular incident that has occurred. So as the workflow finishes, maybe we can just move a little bit to the dashboard. Yeah. So our dashboard is it's called OpsCortex, and then it's for observability, and then how incidents were logged, and also which were AI cleared, and also which needs human attention. So this one is it runs from it's always up, and it receives ingested data from the logs, from the workflow, and then it keeps a sync with ServiceNow. So we can be able to see at a glance the number of active incidents, the pending alerts, how many incidents were resolved today, and the average SLA in hours. So the dashboard will be rich, because it will also have other section to show, maybe the solution implementation, the root cause analysis, also the knowledge base. We will also have we will also connect this solution to a knowledge base, where we can be able to even have operational runbooks. So this first step was just about logs ingestion and correlation, as well as classification. So we have other more steps on how an issue can be able to be resolved by AI. Others can be human AI collaboration. Yeah. Then we also have the trends and the SLA performances. And then, of course, we have an alert and incident panel, where you can be able to see the color-coded badges, yeah, again, this is configurable in each organization. Yeah. So again, linking back to ServiceNow and n8n. So every item you see on this dashboard has a full traceable chain back to the n8n workflow, the ServiceNow ticket, and the originating log in GCP. So for example, clicking on alert ID could open its ServiceNow incident page, display the same description, maybe a ticket like a ticket number in GCP. Yeah, and then this is a kind of cross-platform visibility that will ensure modern incident management, because it will eliminate duplication and keep every action auditable. Yeah, so as we finalize, so what we are building is more than just automation. It's a prototype for autonomous IT operation. So the pipeline will be able to detect, interpret, and escalate events on its own. Again, it will bring intelligence to the IT support, the network operations center, and the service operation environment. If we could take this further, we could integrate remediation steps. Maybe, for instance, if the issue is out of fix possible, the workflow could automatically restart the service, flash a cache, or even trigger a rollback. Remember, we are going to be even storing runbooks, operational runbooks, of how maybe if you want to fix something, you'll be able to fix it. And then we will also have a knowledge base where which will be updated with a high frequency, so that the workflow stays intelligent and ahead of things. So we could also feed structured output to the dashboard or machine learning models that can track incidents and trends over time. So this type of integration will mark a shift from just monitoring to understanding, and from just alerting to acting. So the foundation here is to ingest, to classify, to aggregate, to escalate, and to notify. All autonomous, all traceable, all auditable. Yeah, and that will be able to ensure our workflow is complete. So as the analysis is still in progress, maybe we can just look at an example of an AWS certificate expiring. So let's say a certificate is expiring soon. Let's say in 30 days, or maybe let's say in 60 days. So a log will come in from the connection of AWS Certificate Manager, because n8n has all nodes. So we can say AWS Certificate Manager. So this one will continuously monitor the certificates expiry, the certificates which need actions. And then remember, we're going to be storing a knowledge base and also an operational runbook. So once we get the log ingested that the certificate is going to expire, we will run this particular workflow as the first workflow, because we will have other workflows to take care of how an incident will be sorted. And then so the first workflow is to receive the log, and then it will ingest, and then we will classify this as a certificate that is expiring soon, and then we'll have details of the log itself. So after that, we will fetch. So another workflow will come in, another AI agent will come in, and then it will fetch the operational runbook that shows how to renew, or the steps to renew a certificate, like just running the commands for OpenSSL, what size, yeah. And then after that, it will be able to even send it to an issuer, and then you can be able to get our certificate back. And then after that, we will again connect to the AWS certificate node. So this one is an example using AWS. After that, we can be able to renew that particular certificate without, maybe with minimal human intervention, so that a human can be able to even focus more on other value added support, or yeah. So it's not entirely to replace humans, but to be able to even work more on other issues that require maybe human attention. So if an issue is out of fix possible, so the AI agent will be able to tackle it. And even so they will we will move SLA breaches to now SLAs will not be breached anymore. Yeah. So I think that completes the walkthrough. See you next to our next video, that we will be able to show how this particular issue that was classified and logged in ServiceNow, how it was able to be created on ServiceNow, and how it was able to use the runbooks and solve that particular issue. So from here, you can be able to see the classification has been done for the 500 items. The 500 items we ingested. Then we've been able to do aggregation. Then we've been able to classify from 500. We've been able to classify 40. Yeah. Then we will be able to create an incident on ServiceNow. Let's see. So this one is a dev instance for ServiceNow, and you can be able to see the incidents creation. So let's see. So yeah, you can see the create an incident has completed successfully. And then from here, you can be able to see we've been able to log these particular incidents. So yeah. Okay. So bye. See you next on how to resolve an incident that has come in. Bye for now.